All right, this is problem number 22. Really not much different than any of the preceding problems. Again, it's Bayes' theorem. We're given a little data table here that has proportions of different types of drivers and then the probability that one of those drivers got into an accident or had at least one accident. So I'll go ahead and start with a visualization just to further solidify any lack of understanding about how Bayes' theorem actually works. So we've got 4 categories of drivers. Teens are about 8%. Young adults are about 16%. People in midlife are about 45%, so that makes up the majority. And then seniors are about 31%. And each of those categories has an associated probability with how likely it is that they get into at least one accident. Teenagers are the most likely, so let's represent 15% right here. Young adults at 8%. People in midlife, least likely to get into accidents at about 0.04. And then seniors, slightly more likely at 0.05. So all that Bayes' theorem is doing, this conditional statement here that we're given, it says, given that a driver has been involved in at least one collision in the past year, so that's saying limit your sample space to this area here. Calculate the probability that the driver is a young adult driver. So young adults is this column here. So we're just going to take this area and divide it by the sum total of all these areas. So let's go ahead and write out our fraction. 16% of the total times an 8% probability of getting in at least one accident. And then all of the different ways we could have gotten to at least one accident are going to be down here on the bottom. So we'll do 0.08 times 0.15 to take care of the teenagers, plus 0.45 times 0.04 to take care of the midlife, this area here, and then 0.31 times 0.05, this area here, to take care of the seniors. Turn all of that through the calculator, and you get about 0.22. So the correct answer here is D, nothing too challenging.